So hi, everybody. Welcome to Data Analytics. We left off here from yesterday, so I'm going to give us a quick recap of what we did, okay? A quick recap. So yesterday we started here with section 1.1, an overview of statistics. I think Noella quickly read the objectives onto us. What is the definition of statistic? And we went over what is data. We talked a bit about what is data, and data consists of information coming from observations, counts, measurements, or responses. You guys took a look at the second example, and we talked about or answered three questions. What is your data in this example? Where does it come from? And what is the claim? We discussed it together. It was nice. So let's move on to what is statistics. Okay, what is the science of statistics? This is your science of collecting, organizing, analyzing, and interpreting data. Collecting, remember, I had you kind of help me collect data about this class. When I sent you that Excel spreadsheet, I was collecting data about you. But I kind of organized it for you as well, because there were a lot of drop-down menus so that people will not enter things anyhow. That was a way of me organizing my data. Where I had you freestyle is I'm reading about you. So it's your opinion, it's individual. But most of the time I was pretty much organizing my data when I was grouping the type of hobbies, or when I was talking about what is your occupational interest. That was a way of me organizing my data. Even when I had you pick the public university or private university of interest, that was a way for me to organize my data. And now we'll talk a little bit about analyzing and then interpreting. We will do that in the days to come. It's going to go by fast, but I trust we'll be able to handle all of this. All right, so it's the science of collecting, organizing, analyzing, and interpreting data in order to make decisions. Now, there goes data sets. Data sets, there are two types of data sets. You either have a population or you have a sample. A population, okay? A population is a collection of all. This is your keyword. Collection of all outcomes, responses, measurement, or counts that are of interest. And a sample is a subset or a part of your population. You can have two types of data sets. You either have a population or you can have a sample. Population is a collection of all outcomes, and a sample is a subset of your population. Think about it for a minute. Population is a collection of what? All responses, all measurements, all counts, all responses, all outcomes. And your sample is a subset or a part of your population. All right? Let it register in you, let it sink in you. Yeah. Okay, so let's take an example. I'm going to model for you in this example. In the following one, you guys will get to discuss, and there will be a share out. So here is my example. It says in a recent survey, 834 employees. This is a survey. 834 employees where? In the United States, were asked if they thought their jobs were highly stressful. Of the 834 respondents, 517 said yes. It says identify the population and the what? The sample. And then it says what? Describe the sample set, the sample data set. So they want me to what? To identify the population. What is the population? They want me to identify the sample. What is the sample? And then they want me to describe the sample data set. Okay, that's what they want me to do. Let's think for a minute. It's a survey. It's in the United States of America. They're looking at employees. They ask them a question. Do you think your job is stressful or highly stressful? And out of those 834, 517 said yes. And it says, identify the population in the sample. Remember, your population is a collection of all outcomes, all responses. So what do you think? What do you think is your population? What do you think is your sample? What do you think could be a description of your sample data set? What do you think? I'm going to give you guys about a minute to just talk about it. So you can pause the video here. Let's come back in a minute. So coming back, here is my response, and let's see if it matches with yours. So population is supposed to be a collection of all possible outcomes. So I'm going to say here that my population will consist of responses of all employees in the US. Remember, they took out a survey. So they did not consult the entire population. They just took out a survey. So it's a part of the population. So this is a sample. So this sample consists of the responses of the 834 employees in the survey. That's what we have. 834 employees in the survey. That will, the responses from those people, that's going to be your sample. But now, how do we describe the sample data set? So in this sample data set, this is a subset of all employees in the US, right? So here your data set consists of how many yeses and how many nos. So you have 517 people saying, yes, my job is highly stressful. And you have, if you subtract 517 from 834, you get 317. 317 people or 317 respondents saying, no, my job is not highly stressful. So population collection of all outcomes, right? Responses from all outcomes. So in this particular case, your population will be made of all employees in the USA. The sample here are only those 834 people that you surveyed. So 834 people here responded in the survey. That is your sample, part of your population. And finally, when you describe the sample data or your sample data, you look at the yeses and the nos, where you have 517 people saying yes and 317 people saying no. When you add 517 to 317, you get back the 834. So that is description of my sample data. Okay. So I kind of responded. So this is it. This is a schema of it. So this is your population right here, responses from all employees. This is a description of your data set where you had, I believe, people that said yes, people that said no, not in the survey. So responses of employees in the survey, that was what? 800 and what? I think it was 834. And then all of the green will be your population, right? Whatever, but you don't know what that number is. So that's what it is. Okay. So you can fill it in on your own after my class, but you can fill this guy in. What I'm going to do next is we're going to go and quickly look at what parameter and statistic is. Before we do that, do you guys have any questions? If you do, pause the video and ask. Coming back in, let's talk about parameters and statistic. What is a parameter? What is a statistic? Now, this is terminology. Stats is a science, but it's also a way of talking. Same thing like with biology, you have terms. With chemistry, you have vocabulary. Same thing with statistics. There are words that you need to know what they mean, what they are. A parameter is a numerical description of your population. Numerical description of my population. That is a parameter. A statistic is a numerical description of what? Of my sample. Do you see where the difference is? They are both numerical descriptions, but a parameter pertains to your population and a statistic pertains to a sample. So if I'm looking at population, then whatever numerical statistic I get, I'm going to call it numerical description I get, I'm going to call it a parameter. And if I'm looking at a sample, whatever numerical description I get, I'm going to call it a statistic. So for example, if I'm looking at all of the people in the USA, see, keyword, all. Average age of all people in the USA, that's going to be a parameter. Whatever that number may be, it may be 38, it may be 40. Whatever that average age is, that's going to be a parameter because I'm looking at all the people in the USA. That's going to be a parameter. But now, if I'm just looking at a couple of states or 3 states like here, the average age of people from a sample of 3 states, that's going to be a statistics. So do you guys see the difference? Numerical description for a population is called a parameter. Numerical description for a sample is called a what? A statistic. A statistic. I'm going to give you guys about 30 seconds. Let it register in you. Parameter, statistic. If I have a population, attached to it is a parameter. If I have a sample, attached to it is statistic. That's it. Great. Now, let's take examples. We're going to talk here, okay? Take a minute and read. Okay. The question is, decide whether each number describes a population parameter or a sample statistic. So what do I have here? Each number. So the only number I see here is this guy right here. What does it describe? A population parameter or a statistic? Pause the video. So let's come back. So what did you guys decide? What was it? Was it a statistic or was it a parameter? If you said it is a sample statistic, you are right. Because the average of 50 hours per week is based on what? A subset of the population. A keyword here is survey. When you see survey, think about sample. It's based on a subset of the population. It is a sample statistic. It's a sample statistic. Plain simple. All right. So let's move to number 2. Decide whether the numerical value describes a population parameter or a sample statistic. Take a minute and read. Is it a population parameter or a sample statistic, that numerical value? Pause the video and discuss. So what did you guys decide? Is it a sample statistical or population parameter? If you picked population parameter, then you are right. And I'll tell you why. Or you probably discussed it already, but it's a population parameter because you have a population here. It says the freshman class at a university. This is all freshmen at that specific university. The freshman class, there is only one freshman class at that university. So they collected responses from where? From the entire freshman class at that specific university. So that average SAT math score is based on the entire freshman class. So it's a population parameter. So the average SAT math score of 514 represent a population parameter because it comes from where? It comes from the entire freshman class. That is why. That's basically why. Comes from the entire freshman class. Good job so far. I'll give you 20 seconds in my mind and we move to the next slide. All right. So now it says here, decide whether the numerical values describe a population parameter or a sample statistic. I'm going to give you guys a minute to read the example with me. So that numerical value, what does it describe? Population parameter or a sample statistic? Pause the video, discuss, share out. We come back. If you decided that 34% represent a sample statistic, you're right. Because it's based on what? On a subset of the population. A keyword here is random. It's a random check of several hundred retail stores. It's not all the retail stores in the USA or all the retail stores in the world. It's just they pulled out from several hundred retail stores. So the 34% is based on a subset of the population. It is a sample statistic. That's what we have. Okay. Take a deep breath where you are. The 34% is based on a subset of the population. This is a sample statistic. All right. So this kind of concludes, examples on parameters and sample statistic. Now, let's move on to the branches of statistics. There are two branches of statistics, two. Descriptive statistic, inferential statistic. I will not go into inferential statistic. We don't have enough days, but I will do my best to really delve into descriptive statistic with you. We'll look at examples, we'll look at tables, we'll look at graph and charts. What does descriptive statistic do? What does it involve? It involves organizing, summarizing, and displaying data. I want to be able to organize my data. I come in a classroom, I collect, I need to organize it. I need to be able to summarize. What is it that I see in a sentence? And my sentence will be different from my neighbor. because there are a lot of things that you see in your data when you start organizing it. There are a lot of things that you may see about your data just by looking at it. I want to be able to summarize. I want to be able to say the average age in this class is this. Most of the students in this class come from this province of Cameroon. Most of the students here, they go to this university or would like to go to this university. 50% of the students in this class would like to be in the medical field or the healthcare field. See, I'm summarizing the data that I looked at, your data that you entered in. That's it. And now, once I summarize, I want to be able to display, because people like pictures. Most people are visual learners. We want to see charts. We want to see pie charts. We want to see tables. So this is the displaying part of the data. So we're going to do a lot of this in the days to come, okay? And we can infer from it, that is drawing somewhat of a conclusion. Now, to infer, we move into the inferential part of statistics. That is, involves using sample data to draw a conclusion about a population. For you to collect from the population, remember, population is all responses. For you to collect from the population is very expensive. So most of the time, what do? We get a sample, part of the population. Yes, part of the population. So inferential statistic involves what? Using sample data to draw a conclusion about a population. Okay? All right. We could make inference from past experience, right? I could be a doctor in an office and I've looked at a lot of colon cancer patients, and by your data that has been collected by a research nurse, I can predict how likely you are, to survive this specific cancer. That is based on what? On my past experience, based on the amount of people I've seen with your diagnosis, okay? It's not really, it's based on data, yes, somewhat, right? So I'm inferring here by looking just at your data. I'm not doing any calculation whatsoever. I'm just looking at what I'm seeing in the data, okay? For example, I could look at your age, I can look at the stage of your cancer, etc. And from there, I'm able to predict what is your chance of surviving. All right. So now let's look at an example. We'll rate it, and then we will determine which part of the study represent the descriptive branch of statistic, or which part represent the inferential branch of statistic. So for each of the study here, we will identify the population and the sample, then determine which part of the study represent the descriptive branch of statistic, what conclusion might be drawn from the study using inferential statistics. Okay, it's a mouthful. So I'm going to give you guys a minute to just read. So I'll do this with you. Talk with a friend. We can yap. We can talk a bit. It says a study of 2560 or 2,560 US adults found that of adults not using the internet, 23% are from household earning less than 30,000 annually. And it's shown in the picture. So here it is. The title is not online, so I'm not using the internet. It says US adults who do not use the internet by household income. So when you look at the bar, or this is more like a bar graph, yes, you can see that 23% represent what? Households that are earning less than 30,000. So households that are earning less than $30,000 in income, right? 23% of them do not use the internet. That's pretty much what it is. If I was to read on the far right, yes, the far right, it says over there that 3% of adults that do not use the internet are from household of 75,000 or more, 3%, and then etc. You can read the other two bar graphs. So what do you think is the population here, the sample? What do you think is the population here? What do you think is the sample? And which numerical description here represent the descriptive branch of statistic, and what conclusion might be drawn from the study using inferential statistics? So we need to, one, I'm going to write it up for everybody. What is the population in English? What is the sample in English? Then which part of the study represent descriptive statistic? And finally, what conclusion might be drawn from the study using inferential statistic? Now, that conclusion could be different from my neighbor's conclusion. What conclusion can be drawn? Pause the video right here and talk about it. So here, your population will consist of all responses from users adults. And we don't have a population here, we have a sample. So here, it's all of the responses, all responses of US adults. But we do not have a population here. What do we have? We have a sample, because the sample that we have consists of what? I believe 2560 US adults responded to the survey, right? Responded to survey. Now, that's my population, that's my sample. Now, what is the descriptive branch of it? Remember, descriptive is all about collecting, summarizing, displaying data. This bar graph, that is the descriptive part of statistic. The bar graph itself is the descriptive part of statistic. Another one is the statement. The statement where you read 23% of US adults that do not use the internet comes from where? Comes from households with income of 30,000 or less. That statement is the descriptive part of statistic. That statement right there. And whether you give me the statement of 12% of US adults that do not use the internet comes from household with 30,000 to 49,999,000 in household income, that also will be a statement out of the descriptive part of statistics. Whether you give me the statement 3% of US adults that do not use the internet comes from household with an income of 75,000 or more, that is a descriptive part of statistic. Now, what is a possible inference? Like I said earlier, a possible inference could be different from my friend possible inference, okay? Let's say if my inference is kind of similar to yours, a possible inference could be that lower income households cannot afford access to the internet. That could be an inference. So lower income household cannot afford access to the internet. See, this is an inference. So this statement is out of the inferential statistic branch. Take a minute, read this. Turn to your neighbor, ask them, do you understand what just happened? Once they say yes, you can come back in. All right. Now I'm going to take an example and you guys will discuss among yourself, share out, and we come back in, okay? Did you guys see how I laid out the example? What is my population? What is my sample? What is the descriptive part of statistic? What is a possible inference? Remember, possible inference means there might be multiple answers, all correct. Okay. So here, y'all take a minute and read. The question you need to ask yourself is 1, identify population. 2, identify sample. 3, what is the descriptive branch of statistic? Descriptive branch. What statement comes from there? And finally, what possible conclusion might be drawn? Pause the video and come back in the next 4 to 5 minutes. Come back. All right, so let's see if my answer and yours are the same. So what was my population? My population here is all forecasters or Wall Street analysts, high-tech earning forecast of all Wall Street analysts. That is it, all of them. The high-tech earnings forecasts of all Wall Street analysts. That's going to be my population. My sample, remember, you pulled out of there. So we pulled out how many? We pulled out the forecast from how many? 300? The forecast of the 300 Wall Street analysts. Yeah, analysts. Yep. Now, what is the descriptive branch? The descriptive branch. I think the statement said something like the percentage, right? It said the percentage. Remember, this percentage is even what is a sample statistic, isn't it? The percentage who incorrectly forecasted high-tech earnings in a recent year. I think they said was 44%. That is my descriptive branch. What is the inferential? What's a possible inference? A possible inference could be that the stock market is just impossible to forecast or difficult to forecast. That could be a possible inference. So the stock market is difficult to forecast even for professionals because these are high-tech analysts, but they're still having issues. 44% are still having issues forecasting. So a possible inference could be the stock market. Hallelujah. The stock market is difficult to forecast, even for professionals. That could be a possible inference. Okay. I'm going to give you guys about a minute to just breathe in and out before we move to the next slide. Read what's on the slide. Let's make sure we are all on the same page. Breathe in, breathe out. Breathe in and out. Ask your friend, do you get what's happening today? Is everything okay? I need you guys to talk. Do you get what's going on today? Is everything okay? All right, let's come back in. We're in section 1.2. Data classification. It's a very quick section. It's very quick. What I'm going to do here is one objectives, and I'm going to need one person to read it. Let's pause the video. Let's have one person read it. So we want to be able to distinguish between qualitative data and quantitative data. That's what we want to be able to do. What is qualitative data? What is quantitative data? Okay. And I'm going to ask you questions because you guys have seen data. I sent you collecting data. I sent you enter data for me. So you should have kind of an idea of what qualitative data looks like and quantitative data looks like. So here is qualitative data. All right, pause the video. Let's have one person read it out loud for us. So qualitative data consists of attributes and labels or non-numerical entries. Example of it could be major, place of birth, eye color. Another example of it would be what? Hobbies or occupational interest. Another example could be what? Could be field of interest, field of study. That's qualitative data. What about quantitative data? Let's pause the video. Let's have somebody read it. So quantitative data represent numerical measurements or counts. What did I just say? Numerical measurements or what? Counts. Qualitative consists of what? Attributes, labels, non-numerical entries. Is that okay? So quantitative, like I said, quantitative data represent numerical measurements or counts. Age, weight of a letter, temperature, BMI, body mass index. Yes, weight of a letter, height of a personage, age. Another one could be what? What did I have in your data that is quantitative data? Ooh. I think age was the only one, wasn't it? I had a lot of qualitative data in there. Yes. I could have had, what else? I could have had a year of study. Maybe I could have placed numbers in there, but that would have been a bit difficult. So quantitative data, numerical measurements or counts. Now, I'm not going to help you guys here. Y'all going to talk about it, come back in. So here is the deal. We read, we look at the table, we describe what we see in the table, and from there, we come back and we talk about which data are qualitative and which data are quantitative. Are we on the same page? So you read by yourself, look at the table, describe with your friend. What does that table signify? What does it give me as information? What do you see in the table? So we discuss first what we see. What do you see with your friend? Then the next thing that you're going to do is answer the question. Which data are qualitative data? Qualitative data. And which data is quantitative? How do you know? We discuss for 2 minutes with our friends. We come back and share out. Pause the video. All right. So when you guys discussed, I hope my answer and yours are the same. What do I see in the table? These are sports-related head injuries treated in U.S. emergency rooms. On the left, I have a type of sports, and on the right, I have the number of head injuries treated. Because I know that on the left, I have types of sport, so it's an attribute, it's a label, then this is going to be qualitative data. And because on the right, I have the number, this is a numerical count, yes? Number of head injuries treated, I know this is going to be what? Quantitative data. Let it soak in with my friend. Let it soak in. Ask your friend, you get what's happening here. Qualitative data, quantitative data. Qualitative is attributes, labels. Quantity is what numerical counts. Yeah? Do you understand what's going on? Qualitative is non-numerical entries, non-numerical, remember, my friend. And then quantitative data, what is that? Talk. Take a deep breath. I'm going to count to 20. We move on. Now let's move on to section 1.3. It's going fast. It is going fast because we have a lot to do today. This is where we talk about data collection and experimental design. It's key and it's crucial that we talk about data collection. What is data collection? What is experimental design? What does it consist of? So there goes objectives for the section 1.3. I want you guys to pause the video and send somebody read it, please. So here we're going to design a statistical study. How do we do that? How do we distinguish between an observational study and experiment? What is an observational study? What is an experiment? Question mark. Another one will be how to collect data by using survey or simulation, how to design an experiment. And this I'm not going to do here. No need. Okay, we don't have the time for it. So those are the 3 bullets I'm going to go through with you guys. So let's move into designing a statistical study. I want you guys to pause this video for me, please, and have them read it and go through it, please. So first, we identify the variable of interest, the population of study, develop a detailed plan for collecting data, collect the data, describe the data using descriptive statistic techniques, then interpret data and make decisions about the population using inferential statistic, identify any possible errors. Now, I'm going to take an example here. It's a good thing that I do take an example. I am going to just capture this here so we can refer back to it. Watch me do it. I'm going to copy this and place it somewhere here where we're going to come back to it, okay? All right. What just happened here? Paste the image. Here we go. So this is a quick recap, right? Identify the variable of interest in the study, population of the study, develop a detailed plan for collecting data, collect the data, describe the data using descriptive statistic technique, interpret the data, identify any possible errors. Now, I'm going to give you guys an example, and then one of the homework for today will be to actually send you guys looking at one of the articles that you uploaded on your flash drive. And from the article, you will have to next day be able to say, okay, these were the variable of interest in this study. This was the population in this study. How did they collect the data in this study? How did they do that? Now, developing a detailed plan and collecting data, they go hand in hand. And now you're going to have to tell me, okay, so this is one example of descriptive statistic coming out of this paper or this study. And finally, how did they interpret? What were some of the inference in this particular research? And if they mentioned any possible errors, I want you guys to mention it right back to me. Hey, this is a video. You guys will have a chance to come back to this because this is going to be one of our homework. All right. I'm just going to come up with a random example because I worked a lot in data management and epidemiology. So I know of a lot of stories. So, but listen to what I'm saying right now. Imagine your research question is this. What okay, the research question could be, is the length of stay of a colorectal patient, let me write it up, is the length of stay in the hospital of a colorectal patient, colorectal cancer patient at St. Luke's Hospital affected by his or her BMI. Look, here goes my research question. Is the length of stay in the hospital of a colorectal cancer patient at St. Luke's Hospital affected by his or her BMI? Do you know what the length of stay is? I'm going to say affected by his BMI and type of surgery. Here we go. Length of stay will be the amount of time the cancer patient, colorectal cancer patient, will stay in the hospital after surgery. Okay. I'm going to give you a clue. Type of surgery. Underneath type of surgery, you could have an open surgery. You could have laparoscopic. Oh, laparoscopic. I'm not really good at spelling. Remember, I did math. Laparoscopic surgery. And then there could be another one. Ooh, laparoscopic, it could be a combination of both. So it could be a combination. I'm going to say combination of both. It could be a combination of both. A laparoscopic surgery is a very list. What's the name for it? Ooh, it's not invasive. So it's not as invasive as an open surgery. Okay. BMI. Remember what type of BMI we can have. We have normal. We have overweight. We have underweight. And then we can have obese 1, obese 2, etc. So that has to do with your weight and your height. It's a calculation. You guys are biologists, so you should know about BMI. Okay, so I kind of gave you kind of a briefing on this. So, but by looking at my research question, I can already identify the variable of interest. What are they in this particular research question? What are my variable of interest? What's the population of this study? Pause the video, let's talk about it. So the variable of interest, we have length of stay, we have type of cancer, right? We even have, yes, hospital name or location of hospital. We also have BMI, and then we also have type of surgery. You guys see that? Those are my variable of interest. Now, what is the population in this sample, population in this study? That will be all of the colorectal cancer patients in the world. Hello. But guess what? We're not looking at all of the colorectal cancer patients in the world. We're looking at just what? Colorectal cancer patient at St. Luke's Hospital. That's a sample. So all of the colorectal cancer patients in the world. But remember, we're only looking at what? We're only looking at colorectal cancer patients that actually walked in and registered and diagnosed in St. Luke's Hospital. Now, develop a detailed plan on collecting the data, collect the data. Now, this has to do with your research team. How are we going to collect data? Now, I've seen it done many ways. If we're giving a survey out, it could be electronically or it could be paper-wise. You have research nurses that are going to survey the patients that have been diagnosed with colorectal cancer. They're going to ask them specific questions. They're going to collect data about what was their length of stay after surgery, what type of cancer we all know it's colorectal cancer patients. They're going to just pull out of the data colorectal cancer patients. And then they're going to look at BMI. What were their BMI? For that, they need the height, they need the weight. They're going to also collect the type of surgery. You can have researchers doing that. You could have research nurse doing that. You can have somebody specific in the team, a clinician that does that. You could do it paper-wise by talking to the patient. That's very tedious. You could do it by sending electronically a survey or a data sheet. We never send a data sheet to patients. They will never enter data. We can send them an electronic survey in the email or their phones. Nowadays, it's very easy, or you can have somebody telephone call them. But now, to make sure that you don't have missing data, you can follow up when you realize that, okay, they had 2 weeks to enter this data or 2 weeks to enter this survey, do this survey. They didn't do it, you call. Sometimes you have people going to patients' houses to collect that data. Yes, sometimes you do. Or we wait for them to come in the hospital for their visits or their checkup, and we collect that data as well. Are we listening to one another? So that's a way of collecting data. Now, describe the data using descriptive statistics. Now, this has everything to do with, once I have my data in my spreadsheet, I organized it. I made sure there was no mistake. There was no double entries. There was nothing that looks extreme, because you can have a BMI that is so extreme, it throws the entire BMI variable or data on the BMI off. And you wonder, did I make a mistake? So you go back and look. But what happened when you have 1,000 patients or you have 10,000? What do? Then what you do is you start looking at charts. You can look at box plots. You can look at histogram. When something is an outlier, you're going to see it over there. You're going to see your data right here. You're going to see that little thing over here or over there, whether it is way over there or whether it's way over there. If it's an extreme measure, you will see it by looking at your charts. And then you'll be able to locate that patient and say, oh, let me see if somebody made a mistake. Let me see if, in fact, this patient is an obese type 3, okay? And then how do we interpret the data? And this is where inferential statistics comes in. We ask questions, we make tests, but this is the easiest part. 5 is the easiest part. The tedious one is to really zoom in on what we need to look at. Who do we need to collect data from? That's the tedious part. Then develop your plan to make sure that you have a randomized sample. That is, it's going to be representative of my population. Randomized sample. Y'all can look at this as a homework. What is a randomized sample? What is a randomized sample? Y'all can look at it on your own. Okay, homework. All right, take this in. Pause the video, discuss with a friend, and let's come back. What just happened here? What did we just talk about? What was the research question? How did she identify the variable of interest? What was the population in the study? How can we possibly collect data in this specific example? Talk with a friend. Let's give us about 3 minutes. Pause. Let's come back in. All right, so coming back in, let's talk about data collection. There are so many ways we can collect data. I just talked about survey. You can use an observational study. An observational study is where a researcher observes and measures characteristics of interest of parts of a population. So researchers, they observe. This is a keyword, and measure. So for example, researcher measured the amount of time people spent doing various activities, such as a paid work, childcare, socializing. That's an observational study. Researcher measured the amount of time people spent. How would you know? You have to observe. The amount of time people spend doing various activities, such as paid work, childcare, and socializing. Experiment. What is an experiment? Another way of collecting data, you can use an experiment. This is where you have a treatment that is applied to a part of a population, and you call that the treatment group, and responses are observed. And another part of the population may be used as a control group in which no treatment is applied. For example, how do we create the vaccine for malaria? Is via an experiment. You're going to have a treatment group that's going to take the malaria vaccine, and you're going to have a control group that's not going to take anything. And then you're going to be able to measure the effect. Okay, so a treatment and a control group. For example, let's take an example before I come and talk about the placebo effect. It says here, an experiment was performed in which overweight subjects were given an artificial sweetener, sucralose, to drink while a control group drank water. After performing a glucose test, researchers concluded that sucralose affects the glycemic and insulin responses in patients. In overweight people who do not normally consume artificial sweeteners. So look at what they were looking at. They were looking at overweight subjects taking an artificial sweeteners and figuring out whether or not it will affect their glucose or their glycemic and insulin responses. So literally, already you know that people in this experimental group or treatment group, they all have to be overweight, yes? And then they have to make sure that they're not used to consuming artificial sweeteners. That's key. And now in the treatment group, they give them what? Sucralose. And in the control group, they will give them what? Just water. And at the end, what do? They perform a glucose test to see their glycemic and insulin responses. Is it high for the treatment group? Is it low for the control group? It should be. Is it the same? What do you see? So in many cases, subjects in the control group are given a placebo. Placebo is what is a fake treatment that is made. So it's a fake treatment that looks like the real treatment, because guess what? In a blind study or a blind experimental study, the people in the treatment and control group should know what they're taking. They should not. And sometimes we have double-blind studies where even I, the nurse or the doctor that's giving whatever, I don't know what they're taking. That's double-blind study. So me, the investigator, I don't know what I'm giving them. They, the recipient, they don't know what I'm giving them. It's double-blind. A placebo effect or a placebo is what is a harmless fake treatment that is made to look like the real treatment. So far, there are many ways we can collect data. We can collect data via an experiment. An experiment, you have a treatment you're giving to, a part of your population. We call that the treatment group. And then you have a placebo that you give to your control group, correct? That's your fake treatment. And nobody should know what they're taking, yes? And then you measure the effect of the treatment on what? On your sample. Now, another way is via an observational study. You observe and you measure. I'm observing the amount of time it takes for people to socialize, and then I measure that specific characteristic on part of the population. That's an observational study. So here we're going to go into an example together. This is where we yap, we talk, we chat. So determine whether each study is an observational study or an experiment. Step 1, you read. Step 2, with your friend, you can discuss. Is this an observational study? Is this an experiment? Once you figure it out, then you have to be able to answer the question, why is this an observational study? Why is this an experiment? And let's come back in. Y'all can pause the video. So let's see. Researchers study the effect of vitamin D supplementation among patients with antibody deficiency or frequent respiratory tract infections. 70 patients received 4,000 IU of vitamin D3 daily for a year. Another group of 70 patients receive a placebo daily. All right, I have some keywords here. So y'all should have answered this is an experiment. Why? Because you have a control and a what? And a treatment group. All right, what is it that they are studying? The effect of what? Of vitamin D3. So the treatment is vitamin D3, yes? So they're taking 4,000 IU vitamin D3 daily. And then you have a control group of 70 and you have a treatment group of 70. Okay, so the control group is taking a placebo and these guys are taking the vitamin D3. And at the end of the day, what do? We measure the effect of that supplementation among patients with antibody deficiency or frequent respiratory tract infections. So in this study, still, the patients of interest, they either need to have what? Antibody deficiency, or they need to what? To have frequent respiratory tract infections. Now, what do they do with these people? In this sample of all of these people, yeah, with these issues, antibody deficiency, frequent respiratory tract infections, they split them in two, treatment, control. In the treatment group, what do they give them? They give them a vitamin D3 supplementation. And in the control group, they give them a placebo, which is a harmless whatever that looks like the treatment, but it's not. And at the end of the day, what do? They measure the effect of that supplementation among these patients. Does that make sense? So this is an experiment. This is a what? An experiment. Okay. Let's do this again. I'm going to give you guys time to talk. Determine whether each study is an observational experiment, an observational study, or what? An experiment. So step 1, I read. Step 2, I look at keywords. Step 3, I determine whether this is an experiment or an observational study. Once I make my choice, I talk with my partner. What is it? What is it? We agree, we disagree, we agree. We talk about the why of it, and we come back in. Pause the video, please. All right, so researchers conduct a study to determine how confident Americans are in the economy. Study how. Researchers call 30, 40 US adults, ask them to rate current US economic conditions, whether the economy is getting better or what? Worse. What am I doing here? This is an observational study because you're doing what? You observe and you measure. You're not influencing the responses of the subject. You're just observing. They give you an answer, you measure. So how confident? The how is my keyword. This is an observational study. All right. Take a deep breath in and out wherever you are. We're going to count to 20 in our mind and we come back. Okay, still in data collections, another way to collect data is via simulation. Talk to your partner, say simulation. 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 So this is where I use a mathematical or physical model to reproduce the condition of a situation or process. It often involves the use of computers, allows you to study situations that are impractical or even dangerous to create in real life. It often saves time and money. For instance, automobile manufacturers use simulations with dummies to study the effect of crashes on humans. We have an advertisement that goes on TV here where you see a dummy in a car, right? Let's say it's a Toyota. What is it that I see people driving all the time? Hyundai, yes? And then we see the dummy in the car. They're right here, and there goes a wall. and we see the car going towards the wall, and it goes and it crashes, and we see the balloon comes out, and we see how the dummy bounced off the balloon. What is it that you're trying to measure here? How safe the car is. Is it safe even in an accident? Is it safe even in a crash? Now, are you going to have real people in that car while doing that study? No, you cannot. People are going to sue you. So they put dummies in the car. They put the dummies in the car, and then they simulate. They use a mathematical model to reproduce the conditions. In this case, it's a physical model, right? They use coding. They do their little work there. It saves time, it saves money. But guess what? They reproduce an impractical situation, a dangerous one at that. And once they do that, they're able to study the effect of crashes on humans. They're also able to determine how safe the car is compared to another car, maybe. Yes. Likely to look at recovery of dummy, or even when the balloon pops out, do you deviate? Do you get knocked off? Do you get an injury somewhere? They look at all of that, but they have to use a simulation. So that's a way of collecting data for this particular study. Did you get that? Ask your friend, did you get that? Another way of collecting data is survey. Survey. This is an investigation of one or more characteristic of a population. Guess what? I've been surveying you. From the moment we got in this class, I started surveying you, whether it's with the skill assessment survey, whether it's with the data collecting that I've had you do for the past 2 days. I'm surveying you because I'm looking at certain characteristics of my population, not population, but samples of what? Of transitioning students in the city of Yaoundé. Maybe not only Yaoundé, maybe the neighboring cities, but I'm looking at lower opposite kids, and then first year, second, third, fourth year, and maybe some graduates. How are we transitioning into university life? You know, I'm looking at your interest. I'm looking at your hobbies. I'm looking at what encompasses your dreams. Why do you want to be a pharmacologist? Why do you want to be a doctor? We're investigating some of those characteristics. Yes. Surveys are carried out on people by asking them questions. Yes, we're asking questions commonly done by interview, internet, phone, or mail. Now, I've been doing it via internet. Yes, I've been doing it via interviewing as well, because Shania has been asking questions. When you come out of the classroom, people are asking you questions. We want to know more about you and what is next for you. Now, in designing a survey, it is important to word the questions so that they do not lead to biased results, which are not representative of a population. Biased results. What my friend says affect what I say. It's not necessarily what I want to say, but because maybe 10 people before my friend said the same thing that I'm saying, the same thing. Now, guess what? That's going to lead to biased results. Everybody in the room wants to be a doctor. Then I want to be a doctor too. But is it your interest? My parents, my aunties, my uncles, they're all doctors. Therefore, I have to be a doctor. Hello. Isn't this bias? So, in designing a survey, it is important to word the questions that do not lead to a biased results. Something like this. Hey, Sonia, your friend Vanessa wants to be a doctor. Don't you want to be a doctor too? Isn't that a question that's going to lead to a biased result? Imagine that Sonia is Vanessa's best friend. And I'm saying, hey, Sonia, your friend Vanessa wants to be a doctor. Don't you want to be a doctor too? Don't you want to be a doctor too? This question is going to lead to a biased result. She might just say yes and move on. It's easier for her to say yes. Because now if she say, no, I don't want to be a doctor, then you're going to ask her the leading question, but why? What do you want to be? What if she doesn't know and she doesn't want to deal with all of those questions? See that? All right. Now, let's look at something. For instance, a survey is conducted on a sample of female physicians to determine whether the primary reason for their career choice is financial what? Stability. The primary reason for my career choice, financial stability. I want to be a nurse in Yaoundé because I'm looking for financial stability. I want to be a doctor because I'm certain that if I land a surgeon job, I'm going to have financial stability. So we are conducting a survey on a sample of female physicians to determine whether the primary reason for their career choice is what? Financial stability. So in designing the survey, it will be acceptable to make a list of reasons and ask each individual in the sample to select their first choice. It will be reasonable. It will not be reasonable for you to just have financial stability as the only reason in the survey. It will be reasonable for you to list other choices: financial stability, home life balance. It could be it could be what? It could be plenty of reasons. I just can't think of them. But when you design that survey, it will be imperative for you to list reasons and ask the people that are taking the survey to just select their first choice. That way, not everybody's going to stumble into financial stability. But you're going to have some people that are going to say, oh, I'm looking for work-life balance. Some people are going to be like, I want to follow into my parents' footsteps. Some people are going to be like, yes, I'm looking for financial stability. You're going to have plenty of reasons coming through. All right. So let's look at some examples. Oh, this is the end of the day. This is not the end of the day, because I don't know how long I spent here, but this is the end of what I'm going to cover in this particular lecture today with you. I know you guys love to hear my voice, but there's something that I'm going to have you do today. There are three key elements of a well-designed experiment: control, randomization, and replication. I want to be able to control. I have a treatment group, right? I need a control group. Randomization means I randomly picked people to get into both groups. I randomly picked patients to get into the control group or the treatment group. Now, I measure the effect. Can I replicate? If I take another sample with the same characteristic of the previous sample, am I going to have the same measure or the same effect on this second sample? So it's key of a well-designed what? Experiment. All right. Imagine you're looking at coming up with the vaccine for COVID. And we saw plenty of vaccine: Moderna, Pfizer, Johnson & Johnson, etc. Before you put those vaccines on the market, guess what? They went into an experimental phase where they had a treatment groups, control group. They made sure it was randomized, and then they were able to replicate the same thing on a second sample, and etc., before shooting people in real life. Are we all on the same page? So I'm going to need you to be able to explain in your own words what is control, what is randomization, what is replication in an experimental design. All right. And read the rest of the slides. I'm not going to go over those. You can read on your own at your own time. This is college life. This is what we do. We are professional college students. We work, we read, we talk, we study. And the homework also, I'm going to discuss it off of this video, but we're going to go and start looking at grouping and then articles that I've assigned for each group. All right. It was lovely to be here with you guys, to talk with you on this video. I hope you guys got a lot out of this. This recording is going to be uploaded in your Google Classroom, and y'all can watch on your own time. And that's it. Take a write down what your homework is, and let's come back in.